Hi, this video is a quick review on solving trigonometric equations. So if you look at that equation, you're probably pretty certain you can solve that. If not, this review is going to be good for you. But before we do that, I'm going to get a little philosophical about your algebra education. And the way I'm going to get philosophical is I'm going to talk about inverse operations. Whether or not you really consciously thought about it, you're always using inverse operations in an algebra equation to solve it. For example, addition and subtraction are inverse operations. So you have this minus 8, you do plus 8 to each side because addition is the inverse operation of subtraction and it kills it. Likewise, the 6 is attached by multiplication, so you do division. The squared, the inverse operation of the squared is the square root. So this just comes naturally to you because you're darn good at algebra solving equations now, but you're always using inverse operations. Some ones that you learned later in your algebra life are natural log and e to the x. They're inverses of each other, so they kill each other in an equation. Well, when you're using trigonometric equations, you have to use the inverse trig functions. So for example, arcsine kills the sine of x. Another way to write that is this notation kills sine of x, inverse sine of x kills sine of x. Same thing with cosine, same thing with tangent, cotangent, all that good stuff. So just remember that the inverse operations that you've come to love and appreciate in regular algebra equations, same thing in trigonometric equations. So in this example, we need to solve for x, and I'm going to show you the work and hit the highlights. Get rid of the 2 by inverse operation of division. And at this point, by the way, I got rid of the minus 4 by moving it over first. But once you get to here, you kind of have 2 options. Option 1, the theoretical algebra way, is to use the inverse sine function to kill the sine, and whatever you do to the left-hand side, you do to the right-hand side, and from there, you get x equals whatever that thing is. And that thing is 7 pi over 6 or 11 pi over 6. But when you look at this, I'll bet you feel uncomfortable. If you do, that's okay. Here's another way to think about this. When I got to this step, instead of using the inverse sine or the arcsine, I could go straight to the unit circle. And I could say, hey, where on the unit circle does sine have a value of negative 1/2? Right there and right there. And those are your 2 answers. Later on, we'll come back and see how to do this problem with a calculator, just for calculator review. All right, let's look at the next question. Oh wait, before I do that, now we had a stated domain of 0 to 2 pi, which means we can only choose values that occur on the unit circle as I take 1 lap around the unit circle. That's why I took those 2 values. On this next problem, the stated domain is only part of the unit circle, so I've shaded this unit circle from negative pi over 2 all the way to pi over 2. This equation looks a little messier, but I'm going to show you the work. And inverse operations moving the 5 over, inverse operations multiplying each side by 4. So I did a times 4 and a times 4. That's how I got that. Now we have to kill the squared. So we square root the left and we square root the right. Remember, when you square root it in an equation, you need the plus or minus there. So at this point, you have cosine of x, and you can use the inverse cosine or arc cosine to kill the left-hand side cosine. So what you would end up having is something like this. X equals arc cosine of plus or minus the square root of 1/2. And as I would guess, you don't like the way that looks. Nobody's brain wants to try to figure that out. So what I'm going to do is I'm going to say at this point, instead of using the inverse operations, let's go straight to the unit circle. Keep in mind that the square root of 1/2 can be written like this or like this, but if you're good on the unit circle, you realize that cosine has a positive value of this right here and right here, which is pi over 4 and negative pi over 4. Now we also have negative values that would work here and here, but they're outside the stated domain. And we'll come back in a little bit and show you how you can use your calculator to solve that in a different way. And one final problem, and I'm using this one. Let me readjust here. I'm using this one to emphasize what happens if you have an infinite domain. Relatively easy equation. Move the 2 over, divide by 4, and we say, when does sine of x equal 1? Well, the sine of x equals 1 only at pi over 2. So that's kind of your base answer, but the deal is pi over 2 is one of the answers, but what if I took another lap around the unit circle? Now I would be at pi over 2 plus an additional 2 pi. If I took another lap around the unit circle, it would be pi over 2 plus an additional 4 pi. And as you figure, you can keep going forever and ever. In fact, you could be taking laps around the unit circle in the negative direction, in which case that same location could be considered negative 3 pi over 2, and then you can keep taking laps around the unit circle in the negative direction. So to illustrate that in math talk, I can say x is pi over 2, and then I take another lap and another lap, or negative 3 pi over 2, another lap and another lap. Well, you don't want to write this and go on forever, so this is a nifty way to write it. Pi over 2 is our base location, and then we take 2 pi, which is one lap around the unit circle, times k. K is any integer, positive or negative, which just tells you how many laps you'll take in that direction. Okay, so that's a quick review on solving trigonometric equations. I'm going to show you 2 quick ways on how you can do problems 1 and 2 via calculator as a good calculator review. Okay, so for this equation, if I wanted to solve that via calculator, one way I can do is graph the left-hand equation, or side, the left-hand side and the right-hand side, and see where they intersect. So I've entered them into my calculator, and I have to do an appropriate window. This domain is 0 to 2 pi. So I choose my x going from 0 to 2 pi. I have to use a little bit of judgment on what to use for the y values, but you can change those if you need to. Okay, so now I'm just going to graph both of these. And there's the left-hand side being graphed, 2 sine x minus 4. Now the minus 5. And what I would do is I would find the intersection points, and I would look for the x values. So I'll show you one of those, and you can figure out the other if you felt like it. I would go to second, then calc or trace, and I would go choose the intersect option. And I'm on my first curve, hit enter. Now I go to the second curve and hit enter. And so I've hit enter on each side of the intersection point, and it tells me, do I want to take a guess? And yes, that intersection point is 3.665. And you probably can't see that, 3.665. And if I would go ahead and find out what is 7 pi over 6, 7 pi divided by 6, 3.665. So you can see unit circle answer, calculator intersect answer. I've now set up for the second problem, and I'm going to show you just an alternative way to use your calculator. Instead of intersecting the two sides of the equation, we're going to look for the x-intercept of the graph. So I've got this big old equation, and what I'm going to do is I'm going to rearrange it. I'm going to bring the 5 1/8 over to that side, so the whole equation is set equal to 0. And when I do that, if you look at the equation that you see at the top, this equation is really that with the 5 1/8 moved over. So now in this case, if I set it equal to 0, I'm not looking for intersection points because I'm only working with one graph. So I'm going to look for the x-intercept. I'm going to change my window to negative pi over 2 and pi over 2. All right, and I told you have to use some judgment on the y-axis. And I know that this graph is going to stay very close to the y-axis. So I'm going to go from -1 for my lowest y value to +1 for my highest y value. Now I'm going to graph this thing and see what I get. I have some intersection points, and I'm just going to work with this one. If we can do this one, you can do that one. So second, calc or trace. And I'm looking for the 0 option, or the x-intercept. There's my little turtle. I can send him over to the left of the intersection point. You can do this by entering numbers into your calculator as well. I send him to the right of the intersection point. Now what I should be getting here is the answer negative pi over 4. The calculator says, do you want to guess? Sure, I'll guess. And I end up with negative 0.785. This is the same thing as negative pi over 4 if you plug it into your calculator. All right, solving trigonometric equations using inverse operations and reviewing on the calculator. See ya.